So good day, no? In today's video, I will be explaining to you the fluid flow measurement. So the first topic would be device coefficient. Device coefficient. Under the device coefficients, there are device coefficient, there are topics or subtopics. It would be coefficient of discharge, or just simply C or C sub D. Second is coefficient of velocity, which is abbreviated as C sub V. And lastly, contraction, which is C sub C. So let's start with the coefficient of discharge. Or C or C sub D. When we are talking about this topic, the coefficient of discharge is the ratio of the actual discharges through the device to the ideal or theoretical discharge, which would occur without losses. So by the way, before continuing, I would like you to inform that chapter 6 to chapter 9 is the hydraulics, and chapter 1 to chapter 5 of the book that we are using is fluid mechanics. So welcome to the hydraulics topic or chapters. So continue ta. So C or C sub D equals to actual discharge over theoretical. So later on, you can identify or I can tell you what are the differences between the two. So when you say discharge, so it is Q, and theoretical Q sub T. So let's proceed sa coefficient of velocity. Or C sub V. Accordingly, or based from the book, the coefficient of velocity is the ratio of the actual velocity to the ideal or theoretical velocity, which would occur without losses. So same with the discharge, the C sub V is equals to the actual velocity over the theoretical velocity. Or V over V sub T. Always remember that the discharge or coefficient of discharge is always less than sa 1, as well ang coefficient sa velocity always less than sa 1. And lastly, subtopic for device coefficient is coefficient of contraction. Or symbol is CC, C sub C. So based from here or from the book, the coefficient of contraction is the ratio of the actual area of the contracted section of the stream or the jet to the opening through which the fluid flows. So for example, I will be having an illustration. So in this illustration, you can spot the empirical meaning of the said subtopic. So this is the jet kanina pangagdari. So muna yung flow. So there are a number of devices used to measure the flow of fluids. In any of these devices, The Bernoulli's energy theorem is greatly utilized and additional knowledge of the characteristic and the coefficient of each device is important in the absence of reliable values, and coefficient of device should be calibrated for the expected operating condition. So that is. So ang opening and ang flow niya, we can call it jet. No? So C sub C equals sa area of stream, or simply jet, over area of opening. So for example, ang ani kada ko ang opening, so there is possibility na magamay itong sa jet. Or atong kanani is small a over capitalized A. And again, the coefficients are always less than 1. So, unsa day tumong aning topic na to, tong subtopic? The essence or the purpose of this is that we can know the relation between the three coefficients. No? Relation between the three coefficients. So actual discharge, which is Q, and coming from here, so cross multiply lang, Q over QT. So therefore, atong actual discharge is equals to C times QT. So this is our first equation. Also, Q is equals sa area times B, no? So, coming from last chapter, so therefore, it is, ang A is actual area times actual velocity. And we know, coming from here, na yung mga actual velocity and actual area, no? Kining small a. So, kung ato siyang ipang cross multiply, so it turned out na CC times A, this is for the area, again cross multiply, no? CC equals to A over A times CV VT, theoretical. So our area na, I mean the result of this multiplication is that CC CV A VT, new equation siya, no? Always remember na si AVT equals ni QT. Diba? Theoretical man na ito ang velocity. So therefore, Q equals to CC CV QT. So this is the second equation. So equating the two equations that we have formed. So equating the two equations. Equating 1 and 2. Therefore, di ba Q is C QT equals to kani CC CV QT. So we can cancel the QT. Therefore, our discharge is equal to the multiplication of the two coefficient, which is the contraction and the velocity. So this is now the relation of the three coefficient. So proceed to the next topic for chapter 6. It is Orifice. If you haven't familiarized this, or I mean if you haven't known this, no, if you have no idea about Orifice, so Orifice is an opening, usually circular, with a closed perimeter through which fluid flows. It is used primarily to measure or to control the flow of fluid. The upstream face of the orifice may be rounded or sharp. So, orifice daw, again, it is an opening with a closed perimeter. So, naidwa ka klase no? It is rounded ba ang orifice or sharp edge? So, take this as an example sa orifice. So, this one, this is the rounded. So rounded. Next is sharp edge. So, as you can see, kung sharp edge siya, prone siya it's either ma-lessen or malabo pa ang iyahang ma-flow. No? So, kung ito i-compare ang duha ka drawing or illustration, so there are big difference if using rounded or sharp edge. Anyway, to illustrate you more about sa orifice now. So, I have drawn an illustration, no? So, there are two chambers as well as it caused or it happen or it will create pressures. So, this would be the P sub A and this one is P sub B. In the chamber A, so muna ang source of water or any liquid, no? So, for example, dari ato ang liquid surface or free liquid surface or FLS. And kani, this is our datum. So, datum dari. And therefore, in this area, in this axis, this is the theoretical. And this one is the actual velocity. So this is the edge. And as you can see, what if ang ani lang ang iyahang flow? This one. Pinaana. So, dari na part, this is the section 1. Again, section 1 is always put at the left side sa illustration. When si 2 is sa right. So, chamber A, chamber B. So, kanina illustration, we can formulate BEE or Bernoulli's energy equation between 1 and 2, neglecting head loss. So therefore, using BEE, between 1 and 2, no? So it is E sub 1 equals to E sub 2. So since Kwanman neglecting head loss and there are pressures, so we can solve this, no? Or formulate formula. So V sub 1 squared over 2G plus V sub 1 over gamma plus katong elevation velocity, energy, pressure, elevation, pressure head, velocity head, and elevation head. So V sub 2 squared over 2G plus P sub 2 over gamma plus Z sub 2. So our V sub 1 is VA, no? Mag-base ta sa to ang chamber. Ang leveling sa chamber. Since there is no elevation, kay datum ra ni dari. So 0 atong C sub 1 as well as Z sub 2. I mean V sub actual man and theoretical, so I tend to use, again, this one is the actual and this one is theoretical, diba? Kani. But we use the pressure PB over gamma plus 0. Thinking na may height, no height, no? So we can add here gamma h over gamma. So cancel ang gamma, so h nang nabilin. So therefore, actual velocity squared over 2g plus PA over gamma plus h equals to V sub t squared over 2g plus PB over gamma, right? So when we are solving our V sub t, so cross multiply, or I mean transfer the terms from the other side of the equation, so it will happen na h plus V sub a squared over 2g plus P a over gamma minus PB over gamma. So kung ato siyang ikuan, i-times na to 2g for this whole equation squared. So 2g times h plus VA squared over 2g plus PA over gamma minus PB over gamma. So square root both sides. So V sub t equals to man 2g h times VA squared over 2g plus PA over gamma minus PB over gamma. Square root. And we must let h equals to this one, this one, so that we can manipulate a new and more empirical formula. So h is equals to small h plus VA over 2G squared ng VA plus PA minus PB over gamma. So therefore, our VT now is square root of 2G capital H. No? So this one again, this is the theoretical velocity. What if I want the actual one? So, looking back sa formula na CV equals to V over VT, so our V now is CV VT. So therefore, V, and we have the value for VT, no? Equals to CV times square root of 2GH. So again, this is the actual velocity. And same with the other, no? Q equals to theoretical discharge equals to AVT A times square root of 2GH. So this is the theoretical discharge. Theoretical discharge. So using again the Q over QT. What if I want the actual discharge? So Q equals to coefficient of discharge times QT, right? So we know that Q sub T or QT is equals to, so C times A square root of 2G capital H. Again, this is the actual discharge. The H here is the total head producing flow in meters or feet of the flowing fluid. No, it is the total head. As well as, ano siya formula? Wherein the head upstream minus the head downstream. Diba? Since I already introduced you the capital H, so it's time for us to know the values of H for various conditions. So this is the continuation of our discussion. Values for H for various conditions. So again, H is total head. So as you can see sa first illustration, it is open, no? Open orifice. Again, the orifice is this one. So sa first, ang atong H is equivalent lang po sa H na gamay or small letter H. And next, H equals to H times the addition or subtraction of A over G. No? If mo involve maging acceleration, so ngani na siya. Again, going down is negative, going up is positive. Next one is our H, wherein the two kani are closed orifice. So, the first kanino sa close, ang H na to kay equals siya sa H plus pressure over gamma. As you can see, atong pressure kay 0 na, second pressure and first pressure na siya value because naka-close man. So, ng edge. The other one is, involved siya og, ang last na condition, involved siya og different liquid. So, therefore, our edge now is h sub 2 plus h sub 1 times gamma sub 1 o gamma sub 2 plus P over P sub 2. This is a point 1, dari ang point 2. And pressure dari. So, na siya. What if submerge ato ang orifice? Naka-submerge, no? Upstream, na siya downstream. So, simply, atong waton is that, i-minus na to ang again, do not forget na basta nag-liquid na dyan na siya pressure head. So, ang kuha na to sa first chamber, second chamber, pang minus ito lang mga head, that's why na siya gamay na edge, this one. Dari mo na ilang mga free surface liquid, no? Free surface liquid or free liquid surface, FLS, FSL. Contraction of the jet. So jet na punta, no? So katong extended part sa orifice is vena contractor or contract. Contrata. If I'm not mistaken, this is vena contrata. Ang iyang sukod is divide 2 sa diameter. And this is the area sa orifice and area ni siya sa jet na bi-produce or katong tube or liquid yung gawas. So the fluid flowing is coming from all the direction upstream from the orifice, and as they leave the orifice they cannot make an abrupt change in their direction and they move in curvilinear paths, thus causing the jet to contract for a short distance beyond the orifice. The phenomenon is referred to as the contraction of the jet. And the section in the jet where the contraction ceases is called the vena contracta. No? Mana yung trivia. So, hope na you have learned something sa values for H. No? So, let's proceed sa examples. First example. So, ang first example nato is a volumetric tank, 1.2 meters in diameter and 1.5 meter in height was filled with oil in 16 minutes and 32.4 seconds. What is the average distance? So, ang solution nato, first, kay hatag man siya og diameter, high, filled with oil. Dapat nga nag-oil in 16 seconds and 32.4 seconds. So, ganito gamiton. Q equals to, diba, volume over time and discharge. Another formula for discharge. I mean, sa kung thinking mga density, discharge is volume over time din na siya. Or simply V over T. Diba? That is the formula for discharge. And volume nato is that in terms of diameter, so pi d squared over 4, area na siya times height. Ang time is duha man, 16 minutes and 32.4 seconds. So we convert sa 16 into seconds, no? So 16 diba, 16 minutes, wala na siya if 1 minute, if we times sa 16 seconds sa 60 seconds, 16 minutes times 60 seconds over 1 minute, plus 32.4 second. No? So, pi atong diameter is 1.20 squared over 4 times height 1.50, and this one is 992.4. Therefore, atong discharge is 0.0017 cubic meter per second. As we know, no, times 1,000 ram. So, one cubic meter is 1,000 liter, right? So our answer now is 1.7 liter per second. No? Simply L or just lit ang letter. 1.7 liter per second. So proceed for number 2 example. The second example is we are asked to calculate the discharge in liters per second through a 100 millimeter diameter orifice under a head of 5.5 meter of water. So we assume na ato ang contraction sa coefficient of contract kay 0.61 and velocity coefficient of velocity is 0.98. So we better draw it, no, so that we can understand more. So this is a solution. Anak daw, and then so, ano siya? Given no na 5.5 ang head, 5.5 meter. Tapos, ito ang orifice is 100 mm diameter. As you can see, involved ang velocity or simply ang katong ka or 2 of the 3 sa coefficient. So based on orifice, we can tell na we can use this formula, no? Q equals to CA square root of 2G H. So, na siya dari, no? Ito na form na to ng formula. Actual, it would be actual, then discharge. Tara, this one. Okay, discharge man. So, in terms of discharge, since condition, we are naman po i-inform na basta open and ang lang, typical lang siya. So atong capital H equals sa H na gamay. So H equals to H, which is 5.5 meters. And now ang C, how we can get the C? Ang C, based yapon sa itong na formulate na formula is that ang C or coefficient of discharge equals to Kani C equals to CC CB. So CC CB. Since given man no 0.61 times 0.98. So multiplication of the two, it would be 0.5978. So ito lang i-input ang mga values. And always remember that kaning A is the actual area of the orifice, or based on the orifice. So 0.5978 times ang area sa orifice would be pi 0.1 squared over 4. And ang square root of 2, ang G is 9.81. Ang H is 5.5. So our Q now is 0.0478 cubic meter per second, and convert sa liter. So 1 cubic meter equals to 1,000 liter. Small error now. So our Q now is 1, 2, 3, so 47, no, 487 pala ni, 48.7 liter per second. So this is the answer. So, nga na lang pag-solve, no? Finding the discharge. Next is third example. So given ang illustration, you don't need to do it, no, for yourself, or to have the illustration drawn again. So based from the illustration and the question, we are asked to calculate the discharge through the 140 mm diameter orifice, kani orifice again, shown na natay discharge, or coefficient of discharge 0.62. So first things first, magbase ta sa kanong panghatag ng mga info like discharge na putay kuha niya. So dali ra gyapon ta, Q equals to CA square root of 2GH. And always remember na you look for sa tuang condition, this one. As you can see, our illustration involves sa closed air and napadya pressure. The only thing that comes to our mind is that this one, no? This one is not suitable because of the different types of liquid daw. Pero kani isa naman. But with a twist, since duha man ang pressure, we all need to do is that i-minus lang duha. So na to ang H, no? H plus P over gamma. So therefore, H plus pressure A minus pressure B over gamma. So again, gi-minus ra ang duha ka pressures. Tara, PA and PB. Again, ang pressure is small p sub A, small p sub B. So easy na lang, no, because we have the values na may 3. This is H now. 3 plus ang pressures are 50 and 15 over 9.81. Ang unit weight sa water, this is only water. So our H, capital H, or total head is 6.568 meter. So go na din ta. Q equals to, na may C, 0.62 times area, which is pi. Again, ang area is based from orifice, no? Times 0.14 squared over 4 times square root sa 2 times 9.81 times ang H, capital H, 6.568. So our discharge now, or actual discharge, is 0.108 cubic meter per second. And in terms of letters, so 1 cubic meter, 1,000 liter. So the answer is 108 liter per second. So this is the answer. And pwede po niya siya. So that is the example number 3. Now let's move sa medyo taas siya na solution. Ang example number 4. So the question is a calibration test of a 12.5 diameter circular sharp edge sa orifice. So gatag siya type sa orifice, no? Klase sa orifice which is sharp daw. In a vertical side of the large tank showed a discharge of 590 kilonewton of water in 81 seconds at a constant head of 4.70 meters. Measurement of the jet showed that if it traveled 2.35 meter horizontally while dropping 300 millimeters. Whereas to compute the 3 orifice coefficients. So ang question is involve ang projectile, no? Velocity sa projectile. So bring back sa memories ninyo sa yung statics, nani siya. If you haven't, so I will introduce it to you. Ano daw siya, no? Solution. If this is the calibration test na gigamit, and we don't need to specify jud na sharp edge of orifice. So ano lang siya, and ano, insirit doon na siya. So this one is very common sa board exam. So listen carefully, no? So kani daw is, ang x nato is 2.35 meter. And thinking that ang drop niya kanina linya and sa orifice is y. Ang y is 300 millimeter. Ang total head nato, or I mean head, is 4.7 meters. So base sa ato ang nakita, na observe and nabasa na problem, the only thing that comes to our mind is that ang isa sa mga coefficient that we can solve easily is ang velocity. So I tend to use the velocity first, or we should. So Vt equals to square root of 2gh, no? And again, our h is based sa condition that if it is open, so because we put siya sa h ng gamay, so 4.70 meters. So ato na yung ibutang dari na value, 2 times 9.81 times 4.70. So the theoretical velocity is 9.603 meter per second, no? And we need to solve the actual, no, velocity. Kay theoretical mo to ganina. So projectile man, involve ang projectile na formula. So ang projectile is that y equals to x tan theta minus gx squared over 2v squared cosine squared theta. Ito niya ang formula sa projectile. So given man ang y, and take note na ang y is that if this is the datum dari, so below siya sa x, so therefore it signifies na negative. So diba 300 mm, so convert to millimeter, meter, so 0.3 meters. Our x is 2.35, and may gihatag na theta, so 0 degrees, and minus, no, 9.81 ang g, ang x is 2.35 squared over 9v squared, and cosine squared ang theta is 0. So, take note na ang tangent basta itapat og 0 degrees is 0. So, this term now is 0. Ang nabili nato is puros mga negative 0.3, negative kanina side, negative, and this one. So, we can cross multiply, no? So, dari ang v squared, kaya we are interested to v squared. Pero mukha na itong actual. So, negative 9.81 times 2.35 squared over negative 0.3. No, din siya 9. This is 2 times 2. And ang cosine 0 is 1. No, 1 is 1. So, therefore, times 1 squared. Kaya na may squared ang cosine. So, conduct square at both sides para mawala ang squared. So, therefore, atong answer is 9.502 meter per second. So, that's only sa actual velocity, dili sa coefficient velocity. So, our coefficient of velocity is that CV equals to V over VT, and actually value 9.502 meter per second over 9.603 meter per second, cancel ang second units. Therefore, the value is 9.8989. So, take note, this is should be less than 1. So, tama. Kani yung first answer. Napay another answers, no? And we need to find their theoretical and actual values. Ang discharge and ang contract. Contraction. So, proceed ta sa discharge. So, first, sa actual discharge. So, actual discharge, the formula is Q equals to V over T, volume over time. And since pahirapan man ang volume makuha with the direct value, so we need to solve it. So, W over gamma, no? Sa chapter 1 ni na get-introduce ang formula, and given that na ay 590 of water in discharge, so this would be the weight. So ang ato ating question, it would be 590 Newton. So 590 Newton, therefore atong unit weight is 9,810 Newton per cubic meter. So atong volume now is 0.0601 cubic meter. So ang time is given pod 81 seconds, 590 Newton. So our actual discharge now is 0.0601 cubic meter over 81 seconds. So itong actual discharge is 0.00742 cubic meter per second. So we're good with the actual discharge, and now sa theoretical discharge. So QT, diba kung theoretical is kung naman kanira A square root of 2G H, or simply A VT. Kaya naman tayo VT, V sub T, no? Theoretical velocity. So sa area is sa orifice. So pi times 12.5 millimeters. So it would be 0.0125 squared over 4 times VT is 9.603. So our QT now is 0.00171178 cubic meter per second. No? So we're good for solving the discharge and thinking that it would be less than 1. So C equals to Q over QT. Ang value is 0.00742 cubic meter per second. And sa theoretical discharge is 0.01178 cubic meter per second. Cancel ang unit. So the value is 0.63. And it approves na less than 1 ang actual, ang coefficient of discharge. So proceed ta sa coefficient of contraction. So from the formula na katong C equals to CC, CV, so dito ta maghugot sa tuang solving for contraction, coefficient of contraction. So C equals to CC, CV. So we're only interested sa CC, so therefore cross multiply, so we have the value for C over CV. And at the value sa C, which is 0.63, and the value sa CV is 0.989. So ang CC nato is 0.637. And it approves na less than 1. So we have to summarize our answer so that it's easy for us to reminded na muna niya itong na-solve. So for CV, it would be 0.989, C is 0.63, and CC is 0.637. So these are the answers for the fourth example. So lastly, or last example, no, so that you can be more know sa ato topic. Again, our topic is all about coefficient of orifice, or simply orifice, and as well as device coefficients. So last example. So as you can see, involved na po ang manometer and with the mercury. So I already done the illustration, and what I did is that giana pa na ko siya with-draw and sulod ng manometer and sharp edge, and datum na to is along sa orifice. So the problem here is that oil flows through a pipe as shown in the figure. Determine the discharge of oil in the pipe assuming na itong coefficient of discharge, coefficient of discharge is 0.63. I think nakaingon ko kung ano siya actual discharge kanina, but please be known na this is coefficient of discharge. I'm sorry for that if I have said. Anyway, so let's continue solving. So solution. As you can see, we're interested sa discharge, but with a twist, naa siya manometer. So we use katong sum of pressure head from 1 to 2, something like that. So our problem or solution would be started like this, no? Q equals to CAVT. Right? And we need to form a formula. So what I have learned here is that ato adang kuan pressure 1 minus pressure 2 over gamma is equivalent sa V sub 2 squared minus V sub 1 squared over 2G. So this is the first equation. Sunod, we need to find this one. No? So, Again, no, to solve, no, we need to label, no, sa ato mga interfaces. AB. So, sum of pressure heads. Again, basta involve ang manometer, we should input this sentence. Sum of pressure heads from section 1 to section 2 in meter of oil. So P sub 1 over gamma plus the only thing we can do is y plus convert na to 2 meter and 350 0.35 meter no 1 to A kani pasaka naman ta so minus 0.35 diba? And take note that the conversion would be into into oil. So therefore, di ba oil pa man ni 1 to A. So our mercury muna tong oil. The only thing no kay ilang mga specific gravity. So ang iyang head times specific gravity nila 13.6 over 0.91 for the oil. So again, 250 mm ang sa pipe and sa orifice is 100 mm diameter. And sa SG or sa mercury, 250 converted sa meter, 0.35 and Y is ano. And plus Y, pasaka, no need to convert kay sa oil naman siya, equals to P2 over gamma, right? So we can cancel sa Y as well as we can cancel sa 0.35 connected naman. So P sub 1 minus P sub 2 over gamma, ako lang gikuan para di mo malibog. So gamma so, sa same lang o denominator, so we can as 1 na iyang denominator. So mahimo na ni 0.35 times 13.6 over 0.9 minus 0.35. So P sub 1 minus P sub 2 over gamma equals to 4.88 meter of oil. So this is the equation 2. No? So balik po ta sa mga karaan na topic. From the continuity equation, Q1 equals to Q2. If you have remembered this, no? So therefore, ato ang V sub 1 equals to di ba ang Q is VD sa flow rate, no? So ako na siyang i-direct na V sub 2 squared over V sub 1 squared times V sub 2. So therefore, namatay mga diameter, so 0.1 sa orifice squared over 0.25 squared times V2. So our V1 now is 0.16 V sub 2. So this is the equation 3. So we must substitute equation 2 and 3 to 1. No? So equation 1 is kani And value ang kaning pressure, no, difference ani is 4.88 equals to ato ang v sub given naman v sub 1, so v sub 2 squared minus 0.16 v sub 2 squared over 2 times 9.81. So cross multiply para v sub 2 squared apa na to. So 4.88 times 2 times 9.81 equals to v sub 2 squared minus ato pa ni squared ang 0.16, so it is 0.025 man v 56 v sub 2 squared. So therefore, if aton kaning duha minus na 1 minus 1 0.025, so it would be ang paniya is value is 0.9744. So therefore v sub 2 squared, no, is cross multiply 0.9744 488 times 2 times 9.81 squared both sides. So our v sub 2 now is 9.913 meter per second, and it is considered unsa man siya theoretical. So v sub 2 equals to v sub t. So therefore Q equals to C given 0.63 times pi sa Orifice is 0.1 squared over 4 times kani 9.913. So our discharge, no, actual discharge is 0.049 cubic meter per second. So this is the answer for example number 5. So that's it, and I think and hoping that you have learned something, no, for today's topic about two topics under sa chapter 6, no, supplemented flow measurement, device, coefficient, and orifice. So goodbye and thank you for listening.